Welcome back, everybody. Today we're going to be building a portable lithium power pack to power up this 12 volt 55 pound Minn Kota trolling motor. Most of you guys who watch my videos are going to know that I keep this thing on my little lake bass boat. It's the boat I converted from an aluminum rowboat to a decked out boat with just about everything you could want. But since I'm going to be taking this motor from that boat to my little inflatable boat and back and forth, I need a power pack that's portable, powerful, small, and smart. And if you've been watching me for a while, you know I converted my flats boat from lead acid batteries to lithium batteries. I've got two Lithium 12 volt 100 amp hour batteries set up in series as a 24 volt bank to run this 24 volt trolling motor. And if you watch my other YouTube channel, which is a tiny little channel where I play around with a sailboat, I do a bunch of modifications, I do a little bit of sailing, and I converted all the house power in that sailboat to lithium. And I use Lithium batteries in there too. And recently I bought a little dinghy for it, a little 8-foot inflatable boat that I wanted to test with the trolling motor. So I used a battery that I actually put together myself. I bought these individual cells. There's 4 3.2 volt lithium cells here. I wired them in series and stuck a BMS on there, essentially the brains that controls the charging and discharging of the battery. So I've got some lithium batteries hanging out and I have some options. The first option was to go ahead and make another one of these power packs, and that was a really attractive option because I have this. This is an old box that I've had laying around in my shop for probably 6 or 7 years, believe it or not. Came out of another boat of mine, but the beauty is that these cells fit perfect in here. And even with all 4 cells in here, I still have some room above it to put the BMS in there and still use the tool tray. But the problem is that I want a battery that's smart, a battery that I can communicate with via Bluetooth on my phone so that I can see the charge level and the capacity I have left, so I know what kind of distance I could actually travel on that little dinghy. Because while I'll probably use it a lot for just going back and forth from the sailboat to a dock, I also plan to do some fishing out of that little inflatable boat. And getting up into little creeks and fishing for hours is something I really like to do, powered by a trolling motor. Now, I could just add a smart shunt, and that's a device that you can put on a battery and monitors the amount of discharge and charging, and you can get smart ones that actually have Bluetooth accessibility, but they're expensive, a little more than $100, and I don't want to spend that kind of money. I'm using used stuff after all. So that's where Lithium comes in again. Lithium just put out this 100 amp hour mini lithium iron phosphate battery. It's got all the latest controls in it, high and low temperature shutdowns, and it's Bluetooth accessible. And most important, fits in my box. So the battery actually will leave us a space at both ends, and I plan to use that as efficiently as possible. First of all, I won't be able to get my tray in there, and I do want to carry some little hand tools, not much, just maybe a screwdriver, a pair of pliers, an adjustable wrench, maybe small vice grips, I don't know. That means finding some space for that on these end pieces. And then at the other end, I want to have my trolling motor connector and a USB port so I can keep my phone charged as I'm out there. On the inside, we're going to need to have a 40 amp breaker, and I'm going to use that breaker as a switch as well, so I don't have to have a separate battery switch. That'll run the power to these components and protect the battery and the wiring from any kind of short. I'm also going to mount a small fan, and this is a centrifugal fan that sucks in through the front and blows this way. I want that to circulate air in there and keep that battery cool. And I'll probably drill some small holes just under the lip of the lid. That'll keep water from splashing in, but will keep this ventilated pretty well. So of course the box will be water resistant. It's not going to be completely waterproof, can't be submerged, but I'm a little concerned about what level it's actually going to float at, because I do believe if there's enough water in the bottom of the dinghy, it will float this box. And the question is, will it float it below this component or above it? So let's do a little test and find out. First, we need to fill our tank. Let's see how it does. All right, right there it's floating. All right, I'm going to go ahead and just mark the float line. All right, so that doesn't give us a whole lot of freeboard. And why is that important? Well, because now I know that anything below this is likely to get water coming up to it. If it rains real hard and I don't notice that I'm getting a bunch of water in the dinghy, that means I'm going to put the trolling motor port down below the water line and the USB port above it. This thing is pretty much watertight. That isn't. I'm going to try to place them as close together as possible so we can get both of these components up as high as possible. And when I do this kind of thing, I like to think about the ergonomics, right? So this thing, I'll probably open this little hatch with my left hand and plug the female in with my right hand. So definitely want to have it so the hatch opens from that side. And using my little machinist depth gauge here, I'm going to go ahead and just measure to right about the center. And I want to go in about 3/16 of an inch past this edge because I got to deal with the wall thickness. So I'll add 3/16 to that depth and I'll mark that as my center. And I'll go ahead and draw a line down there so we can line up everything. Hopefully this will fit on the same alignment. I'll do the same thing with my depth gauge and make sure that center line is going to work, and it will. Now I just need to measure the height so I can be sure that I put it in a location where it actually is going to fit. And I need a drill and a battery and a proper size hole saw. All right, that's one. Perfect. So right about now, you're probably wondering why I'm doing the opposite of what I said I was going to do, which is put the trolling motor socket down below the flotation line and then have this on top. I started thinking about it, and my thoughts are that neither one of these are going to be perfectly watertight. The thought is, which one would I prefer to protect the most? Which one's the most important to keep running? And the motor is the one that's most important. So I'm going to go ahead and use it on the top and have the USB ports be the sacrificial element in this if we actually get water that high. All right, so let's go ahead and continue our dry fit. I'm going to need some stainless steel screws, so just short ones. That ought to do it. And to seal all the openings, I'm going to go ahead and use this high performance silicone. And I'm going to clean up a little bit of the squeeze out. And you can get it pretty clean with a little bit of alcohol after the fact. So the next thing I need to fit is my little fan. Now, this is a little centrifugal fan. It has the air inlet on the side and the outlet here on the edge. Maybe like that. So it's drawing it across here, blowing it this way, maybe creating a circulation. Yeah, I think I like that. And I'll just mark the first hole. There we go. And it's just a matter of cutting this bolt shorter, mounting it with locking nuts, and sealing it all with a little bit of that silicone. And I'll have links in the description for all the items that I'm using in this project, including a discount code for the lithium time batteries. That should save us a little money. And I'll try to find a box with the right internal dimensions for the battery, and if I find it, I'll put it in the description too. My plan is to use this packing material that actually came with the battery to wedge the battery in place so it doesn't slide around. Alright, I've got all my packing foam cut to hold that battery up in the box so it doesn't slide around, and I've also chamfered this edge because it's going to be in the bottom, and when I drop the battery in, it should just push in and be able to be wedged in there without getting caught on this thing. So I'm going to glue them together with a little bit of 3M Super 77. This stuff kicks butt. And it's just a matter of putting a little bit on both sides, letting it sit for a little while, and then plopping them together. And this one goes on the other end of the box, and I'll chamfer this as well. We'll go to a razor. That should do it. And what I'm going to do with this one is actually glue it to the bottom. And this piece sits vertical in the far corner where the little toolbox is going to be, and I'll glue this in too. Yeah, just a matter of giving this like 5 minutes to set up. And we'll put a little bit of this spray at the bottom and up the vertical side where we're gonna have that other one. All right, first this end. Make sure the bevel's up. And then the bottom of this one. And then the vertical one. So that has it for all our supports. Now it's time to do all the electrical connections. And this is the last component we really haven't installed. I've been thinking about it. I was gonna bolt it here and have it be part of the battery support so it wouldn't jump up, but I'm feeling pretty confident that this battery is really firmly in there. So I think I'm not gonna mount it to the wall. I'm just gonna double stick tape it to the top of the battery. This way, if I need to get the battery out, I don't have to unbolt this guy, because I know what'll happen. I'll lose all the hardware and I won't be able to bolt it back in. And I still have real easy access to turning this on and off, and it closes perfectly. The negative wire is going to be the easiest one to terminate right here. So I'm just going to put the ring terminal on it and crimp it in. All right, so the breaker actually has a connector in here that's just a crimp connector with an Allen key kind of set screw in it. Hopefully you can see that. The idea is you strip this back, slide it in there, and then crimp it down. Now to keep it dry, there's a little seal that goes around the wire, and then the cover comes up and pushes it up in there and creates a seal around there. That looks pretty good. The only thing, there's no seal down here. So let's see if I've got an O-ring. Let's see. And let's see what I have here. This one looks about right. Yeah, I think that's gonna work perfect. Hopefully I have two. Wouldn't it be typical if you only had one, right? Now I've got another one right here. Perfect. Don't know if you can see that, but we got a nice little O-ring right out there at the bottom of the threads. All right, so I shoved the end of the wire in there, stripped back, and it's just a matter of tightening this up. And I usually prefer to have a ferrule around the bare wire, but I don't have my ferruling kit with me today, so it's gonna be this way until I get an opportunity to put a ferrule on it, or until it goes bad and stops working. There we go. Just a matter of doing this one now. Stick it in there and lock it in with the set screw. And set this down in there. This should create a pretty good seal. You know, instead of double sticking this thing, I think I'm gonna go ahead and use some stick-on Velcro. Just gotta cut it to size. And I did put some double stick tape underneath it so that it'll stick a little better onto this plastic, because there's just a lot of little gaps. There you go. And I'll use the backing from the other one to cut the loop part to size. And we'll put this down right in the middle, and that should do it. And before we get too far along, I want to go ahead and put some holes in this under edge just above where the battery's going to be. So the USB port actually comes with this nice wiring harness with an inline fuse, and the connection is just spade connectors. And what I did was I added these piggyback spades so that I can connect the fan there with spades too. So all I got to do is crimp on some spade connectors on these wires, and then these just get piggybacked right on here. And just to keep anything from hitting these and shorting out, I'm going to put a little bit of electrical tape around them, and I'm putting just a small piece of window screen in here just to keep the bugs out, and that's glued in with some hot glue that I'm making a mess of, and I'm just going to remove the excess so it doesn't get caught on anything. All right, that looks pretty good. We're ready to drop the battery back in there and hook everything up. All right, the only thing left to do here really is to figure out a way how to have that fan come on only when I want it to. So I'm gonna put a switch right here that I can just open this up, turn it on when I know it's gonna be a hot day. This way the fan isn't running when I don't need it to, and it doesn't eat battery capacity that I'd rather use for getting a little more distance with the boat. So I'm just gonna cut the power wire and put some little spade connectors connected it to this little switch, and I'll just hot glue this switch right here. All right, we've got the switch on there, and I'm just gonna rough up this little spot right here so the hot glue will stick and hold it there good. And wipe it down with some alcohol. Just a matter of putting a bunch of hot glue on it, pressing it home, and I'll just hold it there till it cools. I had one more support for the battery, and that's something holding it down. So I cut this thing, put it on there, and then put a little hot glue on it so that when I closed it, it got glued to the lid. So I know that that's nicely sized to hold this down, and that battery should be in there nice and snug, no rattles, no movement. Let's take it down to the lake. Well, we finally got a break in the weather. Looks like the rain's gonna hold off. But you know, it just occurred to me that I never checked the charge status of the battery. Let's check it, and it'll give me a chance to show you the Bluetooth. So all you have to do is upload the Lithium app, click on it, and it'll show the devices you've already linked. And all it does is look for it. So if you're gonna link a new one, you go to Bluetooth, it looks for the device. I know by the number on top of the battery that that's the one. And then we just click on the battery, and there it is. And look at that, we've got 49%. Of course, there's nothing going out or coming in where it's reading the current, and we're showing 13.1 volts. That just goes to show you how dead it has to be for the voltage to really change significantly. But you know what? Let's go ahead and just take it down to the dock and see what it does with 49% charge. And one more thing before we go, I want to show you my toolkit. Pretty proud of this. Check it out. Just about everything you need. The screwdriver is reversible. It's got a number 1 and number 2 Phillips and flat. I got wire cutters, hemostats, a small adjustable wrench, a couple of pliers, and a razor blade. And of course, some zip ties. Always gotta have those. And it fits just perfect. All right, I already installed the trolling motor, and all we gotta do is give it some juice. It's just so nice to have a light power source like this, and I can just set it right there. Of course, I won't be using it on this boat because I've already got batteries installed on this boat. We just plug it in just like we said. There it is. And let's go in reverse. And it feels like we got full juice. And it feels like we got just as much juice in forward. This is about as hot as any battery I've ever used in here has ever been. I'm really going about as fast as this little boat will go. And that's with half the capacity on this battery. All right, let's do another quick experiment. I want to go ahead and check the amperage draw on this thing when we're doing maybe 80% power. And then we'll do a quick calculation and see how long we can actually go with just half a battery. So we'll set the multimeter to amps, and I'll set it to 60 amp max, because I know this thing doesn't draw anything more than that. The first speed, the slowest speed, we're drawing 8 amps. On the second speed, we're drawing about 9 2/3 amps, 9.6 amps. At the third speed, we're drawing 17 amps. Let's see how fast we're going. We're doing 1.8 knots, which is a little over 2 miles an hour. And at steady state, we're looking at right at 16 amps. Let's go to the fourth speed. Right at 19 amps we're pulling. And now we're going right at 2.2, and I saw up to 2.4 knots. All right, so the app is saying that we've dropped down to 48 amp hours and down to 3.1 volts, which I think was about the same. So let's do a quick calculation. If I divide 19 amps into 48 amp hours, I get right at 2.5 hours. So 2.5 hours traveling at about 2.5 miles an hour gives me a little more than a 6-mile range. And that's on a half-dead battery. I'm pretty happy with that. All right, guys, thanks for watching. I appreciate you watching all the way to the end. I know this is a little bit of an offbeat video. we'll get back to lure making really soon. I plan to make a saltwater spy bait. I don't think I've ever seen one out there. What do you guys think about that? Let me know in the comments. And I've got a fishing trip planned too, so keep your eye out for that. And if you're interested in more information on lithium batteries, click on this playlist. And if you're interested in just seeing some lure designing and lure making, click on this one. And I'll see you guys on the next video.